you all doing? Good? Okay, so before I start, I would like to thank whole team of GDG Ahmedabad for organizing such a wonderful event and bringing us all here. So can I have a big round of applause for them? Cool, that gives me the energy to be here on stage. So, my name is Shubhangi Shukla. I work as a software engineer at Dados Analytics, and most of my work revolves around creating web applications using Angular and basically exploring about the intricacies of this framework. So, today I'm going to talk about the latest advancements that are introduced in Angular 17. How many Angular developers are present here? Well, that's not a huge number. So I hope like after this talk, at least you guys will be exploring about this framework. And how many of you like agree with me that Angular 17 is like a rebirth of Angular? Yeah, so for those who didn't raise their hand, I'm saying this because with Angular 17, we have got a new logo, we have got a new documentation, and obviously like many killing features. So over the screen, you can see some the major breakthroughs that are in Angular 17. So I'm going to walk you through with the first three features, which is improved SSR support, new lifecycle hooks, and about the new control flow. The other features will be covered by Deepa. So now let's start with improved SSR support. So before directly jumping into how SSR is improved in Angular 17, I'm going to walk you through about the rendering. So can any one of you tell me what rendering is in simple terms? Any one of you? No one? OK. So we can say that rendering is visual output of our source code. These are some terms over the screen which are associated with rendering. First one is client-side rendering. Second one is server-side rendering. Third is SSG, which is static-side generation. And fourth one is hydration, which is obviously not going to, is related to drinking water. So now, if we see that client-side rendering, it is the process of rendering web applications directly on the web browser. So you can see this block diagram. So what happens is, first the browser requests the website, and then the three major files from our source code. In like for web apps, the three major source files are the HTML file, CSS file, and the JavaScript file. So like the moment browser is requesting a site, server is sending these files to the browser. Then browser is fetching all the required information and is working on rendering the application. So this is how the client-side rendering works. But on the other hand, if we talk about server-side rendering, then we can see that it is the process that involves converting HTML files on the server into a fully rendered HTML pages for the client. Again, I have this block diagram. So what is happening, like browser is requesting a website, and the server is receiving those three major source code files. And now the server is going to fetch the required information from there and is going to render the application. Means the whole rendering or application is being done at the server. Now, this rendered application is then sent to the browser, and then like our browser displays our application. So basically, there are some benefits which like server-side rendering provides over client-side rendering. So like if I talk about client-side rendering, then what is happening like in the time when browser is requesting, browser is doing all the work of fetching the information and rendering the application. So what user is going to see at that moment? Anyone can tell, like what are you going to see? A blank screen, like user is going to see nothing, like either it is going to be a blank screen or a loader element, which we developers usually put. So, but in case of server-side rendering, what is happening, like browser is already getting a rendered application. So obviously, like early rendering is happening means no blank page will be there. So early rendering is happening and user is able to interact with the content sooner. Again, this server-side rendering is useful for mobile devices because they have usually low RAM. So server-side rendering works faster there. Any one of you having any questions that server-side rendering is also going to take some time? I think it must be going on some of the minds. So like, yeah, I agree that server-side rendering takes some time, but it is usually lesser as compared to the time taken by CSR. Now, the next benefit that this server-side rendering provide is of improved core web vitals. Everyone is aware what core web vitals are, right? Like you can raise your hands. Okay, so like for those who don't know, core web vitals are some specific metrics that are introduced by Google to measure the load performance of our application. We are having three major core web vitals, which is LCP, that is largest contentful paint. Then we are having AppCP, which is first contentful paint. And then we are having cumulative layout shift. Now, this SSR contributes to reducing our FCP, which is the time taken to load the first HTML element. And then this SSR is reducing the cumulative layout shift. It is usually an unexpected shift that happens when our application is loading. So with this SSR, this CLS is reduced. And then we are having the reduced largest contentful paint, which is the time taken to load the main element of our code or like application. Now, the next benefit is about better SEO. So let's understand it with an example. So suppose I'm making a website for an insurance company. Now, what I want from your search engine is that whenever any user searches for best insurance company or best insurance provider, my website should appear on top. But how does that generally happens? So there is a process of crawling that is carried out by the search engines on our web pages. So basically, our web pages crawl over the those crawlers crawl over our website and fetches the data that is available. And based on that data, just a second. So based on the data they are getting from crawling, they decide the ranking of our web page. Now, in case of client-side rendering, what is going to happen, like what that crawler will see first? It is going to see nothing because the time the application is loading in CSR, so crawler is going to see nothing. Like crawler is not getting any data. So that is obviously not going to add up to, can I have a water? So basically, crawler is not going to see anything if it is a CSR-based application. But in case of server-side rendering, since browser is already getting a fully loaded application, so that is going to add up to a better ranking of our web pages. Now, if we talk about like what happens in server-side rendering when user is updating a data. So suppose the content over the web pages is being updated, then how server-side rendering is going to work? So the process is repeating till the server is rendering the HTML, process is same. But the moment that the rendered HTML is sent to browser, what browser is going to do at that time? Browser is going to destroy all the previous HTML it had, and it is going to work on re-rendering the whole application, which is not a nice thing. Do you agree with me? So, like with Angular 16, we had this term hydration that was introduced in Angular 16. If we see the definition, then this is the process that restores a server-side rendered application on the client and improves performance by avoiding extra work in recreating the DOM nodes. So again, like if we see this block diagram, so what is happening? The user is updating the data, the server is doing its work, but the time this rendered application is being sent to browser, what browser is going to do now is browser is reusing the HTML it had, and it is only going to work on rendering the updated HTML. So I think this is a good thing. And this hydration was in developer preview till Angular 16. But then like Angular community realized that over 1,000 applications are made using hydration. So now with Angular 17, this hydration is in stable view, like a stable feature. If we talk about the benefits of hydration, then first one, I think I have covered this, but in hydration, like the DOM elements are being reused, and no extra work is being done by the browser in recreating the DOM nodes, and it is eventually preventing the UI flicker. There's this term of SSG. So it is a process where the HTML pages are rendered during the build time. It is sometimes known as pre-rendering as well. So I would suggest, like, if you guys are making any SSR-based application, then you can work together with SSG and SSR. So in SSG, what is happening, like, as our HTML pages are being rendered during the build time, means pre-rendering is happening. So for the static routes, we can have SSG, and for the dynamic routes, we can have SSR. Now, like, I have created this table to see how some things used to happen before Angular 17 and after Angular 17. I hope the things are clear till now. So first one we see is of creating a new application with SSR. So till like Angular 16, we had to give additional ---- SSR with our commands. But from Angular 17 onwards, we just have to give our usual command, which is ng-new and the app name. That in the CLI, we are going to see a new prompt, which will ask us to, like, whether we want to enable SSR and SSG in our application. Second one is of enabling the hydration. So till Angular 16, we had to import this provide client hydration in our root module in order to enable the hydration. But from Angular 17, what is happening is, like, hydration is being enabled by default in all the SSR-based application, which is a good thing, I think. Then the third one is of hybrid rendering. So till Angular 16, the hybrid rendering was carried out by an Angular repository, which is ng universal. But from Angular 17, this repository has been moved to CLI, and we can have a hybrid rendering with this ng add Angular SSR. The fourth one is of deployment. So with Angular 16, we are having an option of a seamless deployment with Firebase with nearly zero configuration. Like till Angular 16, we had to give some additional configuration files in our source code, but that won't happen from Angular 17 because, like, with Firebase, we can have a seamless deployment. So this was all about the improved SSR support. Let's move to our next topic, which is about the new lifecycle hooks. So this, I want to ask one thing. I think in every application, at some point of time, we have to use some third-party libraries, correct? So can you tell me a third-party library which you have used, or most common third-party library in your application that you have used? RxJS is OK. OK. So now what this third-party library expects from a component, like that component should be already rendered, like before that library is initiated, correct? So for this, these new lifecycle hooks are going to help. So the first hook is of after render, which is going to register a callback that will be invoked each time the application has finished rendering. And the next one is this after next render. So it is going to register a callback that will be invoked the next time our application has finished rendering. So now, if you want to use any third-party library in Angular, then you can use it with the second one, which is after next render. Now, these new life cycles are going to help you in these two ways. Like, it is going to avoid unnecessary DOM manipulation, and it is going to provide a safe mechanism for integrating custom DOM elements directly within our components. Now, if we talk about this, I think this is the major change that has been introduced with Angular 17, which is of new control flow. So I want to share one thing. Like, it's been around 2.5 years I'm using Angular, but still sometimes I have to look up for the syntaxes. And I think many fellow developers faces the same problem. Is it? Yeah. So this problem was reported to Angular community. So finally, they have come up with a whole new syntax for the control flow. So now the new syntax is similar to other programming languages as well. And So which is eventually going to reduce, reduce the number of times we are referring the documentation. And the other thing is that this new control flow primarily exists at build time only. So it is eventually decreasing our application bundle size by up to 30 KB. So which is again a very good thing because our Angular application is going to be more performant. If we talk about the comparison, then like I have created some slides for the comparison between the directives which we have in Angular. So first one is this if-else directive. So if we talk about this, then star ng if is being replaced by at if. And we also see that till in older syntax, we have to give a separate template block for our else content. But with new syntax, what is happening, like we are directly putting our content under the at else statement. If we talk about this switch directly, then old syntax seems to be a little more complicated, but the new syntax is simplified and more robust. So like in previous syntaxes, we were having and star ng switch case, star ng switch default, but with the new syntax, we are just having 3 words, which is at switch, at case, and at default. Now, this is about the for loop. So in this star ng for is replaced by at for in the new syntax, and an additional empty block is also added. Means we can collect all our 0 items under this empty block. The other update that we see is that in new syntax, I'm using a track function as well. This track was also available in the old syntax, but it was not mandatory. So this track usually enables the DOM to be updated only for the changed item. So within the old syntax, this track function was mandatory, which it was optional, and it was coming between the, like it was giving some performance issue. But with the new syntax, this track function is mandatory, so it is again going to improve our performance of the application. These are the benefits of the new syntax. I think I have covered all of them except for the third one. So there was a specific issue with star ng switch directory. Do you know about that? Like, have you ever came across that issue? No? OK. So I have added some code snippets for like what that issue was about. So what I have done here, like I have taken enum type, then I'm declaring 2 interfaces, then I'm creating a union type of that interfaces. And then in my class element, what I'm doing is like I'm just giving some object values to the available type. So with older syntax, what is happening, like I'm trying to print that class value with the reason object, but what is happening, like we are getting an error. So that error is like our application is not able to identify the property, like is it there or not. But if we see in that code that available is a union type, so it should have those 2 values. But still, the error is there. So in order to like remove the error, we had to give the type of that union as an any, which is not a nice thing. Like if we are having different types in Angular, then we should use them. We should never give any type to the components. But with the new syntax, like there was like this issue was resolved. So like we are just getting direct output, like the desired output we are getting with the new syntax. So yeah, like this was all about the improved, some improved features in Angular 17. And if you want to connect with me, then you can connect with me over LinkedIn, or you can reach out to me on my mail. So with this, I would like to wrap up my talk. And now I would like to invite Deepa to take over the stage. Thank you.
Hello, everyone. I know all of you guys are waiting for lunch, I guess. And I see the excitement for that. But yeah, before that, let's discuss about deferred loading and signal. Both are very powerful feature of Angular 17, and you have to be aware about that. OK, so first thing I'm discussing about is deferred loading. So basically, what is deferred loading? It is advanced lazy loading. We all know lazy loading. I am sure that all of you guys are aware about it. So lazy loading is basically loading of components on demand. You can load your component or module or anything on demand. Okay? So now what Angular team have introduced is that they have said that we will take our lazy loading to an advanced level. Now you cannot just lazy load your modules or components inside your module itself, but you can mention in the HTML that from HTML only, I am going to tell the compiler that I want to load this component after some time, or I want to, if my component is loading after some time, till then I want to show placeholder. So it provides you the set of conditions, it provides you the set of triggers that you can implement while using deferrable views. So basically, deferrable views is a powerful tool that is used to delay loading of heavy components. Okay, and as I have said, that it is advanced lazy loading. Now, why do we use deferrable views? First, it is to improve the bundle size, same as lazy loading. Second, it improves core web vitals. Core web vitals, as Shubhangi have already explained, it is a set of metrics by Google to develop the to measure the performance of your website. Then next we have improve LCP, your largest contentful paint also get improved by deferred loading. And third, we have time to first byte. Now, how are you going to implement defer block? Now you know, okay, deferrable views are the advanced lazy loading, but how am I going to implement it? That we are going to be discussing right now. Here you can see that I have created a div, okay, inside that app child is inside a defer block. So what defer block is doing, it is telling the compiler that I want to load this heavy component after some time. I want to lazy load it. So that what defer block instructs your compiler. So that's what I have written in the definition also, that it extracts the content and it will inform your compiler that extract it later point of time. And by default, the trigger which is going to be implemented here is on idle. So what Angular team has done, that it have brings so many triggers inside the deferred loading. So by default, if your app is idle, at that time, on idle trigger will happen and your app child component will load automatically. Now, next we have, like we have already discussed that what defer block is. Now, defer block has various sub-blocks. First is optional block, second is non-optional block. In optional block, you have placeholder and loading. So in placeholder, what happens is you already tell that if I have already mentioned that this component will load after some time. So till then, what you are going to show to the user. Till then, you can say that, okay, my component will load after some time. Till then, you show placeholder to the user. So that component you can mention inside the placeholder. So in the definition, you see that it is mentioned that it will show before defer block is triggered. And it also has minimum parameter. So if you want to mention that, okay, I want to show this placeholder for minimum this period of time, that you can mention using minimum parameter. Then apart from that, we have loading block. So now your component is loading after some time. During that time, you want to show your user that, okay, it is loading. During that time, you want to show something. So that content, where you are going to write that. So that content you are going to write inside the @loading block. Okay? And then you have non-optional block. Let's say your defer block have failed. Okay? Now it is not working. So in that case, what you are going to show to the users? That you are going to write inside the error block. Inside that you will mention that if in case defer block is not working, then we will show the message that it is not working correctly. Then next we have use case for it. If you see here, we have defer block. Inside that I have mentioned the large component. Okay, because it is large, so we are going to load it after some time. We are going to lazy load it. Then we have placeholder. I have mentioned that a placeholder will be shown for minimum 500 millisecond. And then after that, and if your component is loading after some time, then inside @loading block, I have already mentioned some image that I want to show during that time. And if in case your defer block failed, then you will see the error block. So that's how you can implement the defer block in your HTML. Next, defer comes with a set of supported conditions and triggers that will determine when to fire the components loading. Now we have already discussed that, okay, it is having several blocks. Now, it is also providing you that if your website is idle, then your heavy component will load. If you are interacting with your web page, then your heavy component will load. If you are entering a viewport, then your heavy component will load. Or if you are hovering over a particular div, then your component will load. So you see, there are several conditions. On the basis of that, you can tell your HTML that you want to load this particular heavy component. So that's what defer provides you in form of triggers. Here you can see that there are two options for configuring. First is on, and second is when. So inside on, we are specifying a trigger condition. Like I have mentioned already, like if it is on idle state, if it is on interaction state, or if it is of any state, then in that case, you are using the on block, on condition. And for other condition, like you want to mention that if my specific property is true or false, like you want to give a proper condition, for that case, you will use the when, because when returns a Boolean value. So Angular provides you both things, that if you want to load your component on the basis of interaction or on the basis of any activity a user can do, for that also Angular is providing you with on triggers. And if you want to load your component on the basis of a Boolean value that you want to define it on your own self, for that it provides you with when. Now next we have defer block. Inside that, like I have already told, when the user enters a viewport, in that case, your calendar component will be shown. And also, if you want to mention a Boolean value along with it, then you can mention it with the when. And let's say your component is taking some time, till then you want to show the placeholder, so it will be, your image will be shown for that. Then, as I have already explained, that defer comes with a set of supported conditions and triggers that will determine that when the component loading will be fired. So here we have on idle. Idle will be when your app is idle, then it will work. On immediate. So the moment your HTML is executed, the on immediate trigger will fired immediately. And then we have our on timer. It is a set timer based trigger. So if you are mentioning that I want to load this component after 5 milliseconds or 5 seconds, then you can use on timer for that. Then we have on hover. Now you are mentioning that if I hover on a particular div, let's say you are having a website and you are having a comment button. So when the user clicks on that button or hover on a button, then only you want to load the component. That you can do with the help of on hover. Next we have on viewport. So if you are you want to load some component only when the user enters a viewport, on that case you can use this trigger on viewport. Now one thing you have to notice here, that when you are using on interaction, then you can use a template reference itself. Like you have created a div, you are declaring the template reference for it, and then when you are executing the block, then you can mention the template reference itself for this. Then I have attached several use cases for it. So you are using defer block. Inside this on immediate is there. So it will execute immediately when your website will load. Next, on timer. I have mentioned that for 500 milliseconds it will wait. Then it will execute your calendar component. Next, we have on interaction. Here you can see I have created a button and I have given a template reference greeting. So the moment you are interacting with that greeting button, your calendar component will fire. Otherwise, it will show placeholder. Next, we have on hover. Here also you can see I have created a div, greeting. As soon as you hover on that div, then your calendar component will fire. Otherwise, placeholder will be there. Next, you have viewport. As long as you are entering a viewport, then this particular component will fire. Otherwise, it will show the placeholder. Now, Angular don't just provides you condition and triggers, it also provides you prefetching. Prefetching can take a set of condition and it determine that, okay, my component will load after some time or it will be basis of some triggers, but till then you load all the dependencies required because I don't want it to take much time. So here you can see in the example that I have mentioned, on interaction, load the calendar component, but till then, when it is idle, it is an on idle state, prefetch all the required dependency associated with it. Now we have reactive signals. Now reactive signals is a powerful feature of Angular that is introduced. So what actually Signal is offering is that it provides our code more reactive. Now I will explain about it later, but let's see what is the definition of it. Signals basically tell our template that the data has changed. In Angular, like we have so many ways to find out that the data has changed. One of is change detection and so many things. But Signal also do this part and it is more reactive. Now, I have mentioned here that it improves the change detection. But now see how does it improve the change detection. So by default, if you are using Angular, so in back, Zone.js, what it does is it compiles the whole application and then it checks that if there is change in the model, then it will reflect it on the view, okay? And for that, so much of JavaScript code is going to be rendered on the client. So much of JavaScript is rendered, so it increases your application time. Now what Zone.js do is it will start your change detection strategy for every possible component. It will start running it for every possible component and just imagine how much time it is going to take if your change detection strategy is running for, let's say you have 50 components and it is running for 50 components. So to solve this problem, what Angular team have introduced is on-push change detection strategy. So if you have on-push change detection strategy, then when a particular component, like here I have mentioned that component X. So if on component X something have changed, then change detection strategy will run only for component X and its parent. So only the parent component is getting affected here. But one thing you should notice that here also, one more component, like one more extra component is getting affected. Technically, only component X should be affected, but here one more component is getting affected. So to resolve this issue, Signal components comes into play. Now, if you are using Signal components, when your component X is affected, then change detection strategy will run only for component X and not for any single component in your slide. Now, I have said that your Signal is more reactive. What do I mean by that? Let's say you have declared a variable X, you have assigned it value 5, then 3, and in Z, you are calculating X plus 5. Then what will be the result of Z? It is the easiest question. 8, right? Now you are reassigning the value to 10. Now again you are printing Z. Now what will be the answer of this question? It will be 8. Because here, when you have calculated once, it will store the value, and when you are changing X value, then Z value won't change. But what we want our code to be more reactive. For that, what we will do, we will use the computed signals. What computed signal does? Let's say you have declared X variable, okay? Inside that, you are using signal, parenthesis, and inside this, you will pass the default value. Then you have second Y. Inside this also signal, parenthesis, default value. Now how you will declare Z? you will declare a computed function. Inside this, you will add both of these signals. Now what happens when you, one thing you need to know, if you will try x is equals to 10 here, it won't work. Because signals you cannot directly reassign a value. You have a method for it that is called set. And you have to use set only. So when you use set, then you will reassign the value to 10. And now when you're printing the z, then it will know that, OK, change have appeared. Now I have to recalculate it again. And then it will show you the updated value. That advantage signal is giving to you. Now, can you reassign the computed signals? No, you cannot. If you try to reassign the signals, then you will get an error. So computed signals are read-only. And otherwise, we have normal signals are read-only and write-only both. What is computed signals? It is read-only, not writable. It is lazily evaluated and memoized. I will also explain that how it is memoized. How to create a signal? Basically declare the variable. You can mention the type, writable signal, and then signal, parenthesis, and default value. What is more definition of signal? Variable plus change notification. It will have a default value. It is synchronous. And you have to remember that it is not a replacement for RxJS. Methods in signal, we have already discussed about set. It removes the earlier value and sets the new value. Then we have update. It will update the signal based on its current value. Now, if you look inside the code, then you will see that you have declared signal with the default value 0. Then you have set it to 3. Now, when you are incrementing it, then it will take the latest value 3, and it will increment it using it. So it will give you the value 4. Now, whenever any change is happening inside the signal, for that, effect will run. So effect is an operation which run when one or more signal value changes. So it will run at least once. Now, after that, how many times your signal value change, effects will run again and again. How to use an effect? You will declare the effect method, and inside that, you can pass the statement. Basically, effect will be used to log the data only to get the updated data. Then we have lifecycle change after signal. First, like if you are not using input or anything else, but if you're using signal, then to know what change, to know that change have occurred inside the signal, you have to use effect method. Then you have after next render. Then you have ng on init and ng on destroy. So basically, if you are using signal, then your life cycle will change completely. That's what Angular 17 brings to the table. So yeah, that is it from my side for deferred loading and signal components. You can follow me on LinkedIn. I post my handwritten notes there, and it is really useful for interview preparations. You can also connect with me on LinkedIn. Yeah, that's all from my side.